So consider two solenoids. Okay, let's say S1 and S2. Both of them, they are placed in coaxial. Okay, they're placed coaxially. See, like this in the given picture. Both of them, they have the length to be L. And then let's say solenoid S1 has N1 to be the number of turns per unit length. Similar way, N2 will be the number of turns per unit length for S2. Okay. See, now what we have, see, let's say we give current to S1. Let's say I1 is the current going through S1. Similar way, I2 is the current through S2. So the flux which is coming from the solenoid 1, okay, that solenoid 1, so sorry, the flux which is from the solenoid 1, that comes and links with the secondary coil, correct? So we can write phi 2,1, that is the flux which is linking with the secondary because of the primary. Okay, so here primary we are taking it to be S1, secondary as S2. So phi 2,1 is proportional to I1, because more current we have in the primary, that is S1, then more flux will be linking with the secondary coil. So we have phi 2,1 proportional to I1. Okay, so what we get is phi 2,1 is equal to M21 into I1. Okay, so proportionality introduces a constant. Okay, now what is the magnetic field of a solenoid? We have B is equal to mu naught Ni. So we have B1 is equal to mu naught N1 into I1. This is basically the magnetic field from the first primary coil basically. Okay, now remember N1 is number of turns per unit length. Okay, fine. See, next what we have the flux linked with each turn of the solenoid S2. Okay, the flux, again I'm telling you, flux linked with each turn. So that will be B1 into A, where A is the area of cross section, right? So B1 into A. So phi 2,1 will become B1 into A into N2 into L, correct? Because the total flux what we are calculating. So that's the, for the one loop we have B1 into A, there are n number of loops, so N2 into L. So we have mu naught N1 I1 A into N2 into L. So phi 2,1 is equal to mu naught N1 N2 AL into I1, right? So this is what we got. This is nothing but the total flux linking with the secondary solenoid, right? Now see what we have phi 2,1 is equal to M21 into I1. We got it from the first equation. So you put that here. We have M21 I1 is equal to mu naught N1 N2 AL into I1. So I1 cancels. So we have M21 is equal to mu naught N1 N2 A into L. Okay, so this is the mutual inductance of the secondary due to the primary. Okay, now similar way what we get, so we have phi 1,2 will be proportional to I2. This is nothing but the flux linking with the primary because of the secondary, correct? So again phi 1,2 is equal to M12 into I2, right? Next B2 is equal to mu naught N2 into I2, the magnetic field from the secondary solenoid. So again we do flux link with each turn of the solenoid S1. So that will be nothing but B2 into A, correct? So what will be the total flux? Phi 1,2 is equal to B2A into N1 into L, right? So substitute the B2 value. So we have mu naught N2 I2 A into N1 into L, correct? So we have phi 1,2 is equal to mu naught N1 N2 AL I2. So again substitute phi 1,2 as M12 into I2. So we get M12 I2 is equal to mu naught N1 N2 AL I2. So I2 cancels. So we have M12 is equal to mu naught N1 N2 AL, correct? Now if you look at this, see these are the two equations, M12 and M21, both are the same, right? So let's call that as M. So we have M12 is equal to M21 is equal to M, correct? So M being the mutual inductance of these two coaxial solenoids. So we have M is equal to mu naught N1 N2 AL. Okay, now mu naught is the permeability, N1 and N2 is the number of turns per unit length of these two solenoids. Okay, the primary and the secondary, or the first solenoid and the second solenoid. Now A is the area of the inner solenoid. Okay, because all the flux will pass through the inner solenoid, correct? So that's why that area we have to consider. And then L being the length of the solenoid. Alright. So quick recap of what the derivation was. So we have two solenoids, S1 and S2. So the logic behind this is we try to calculate the flux linking with the secondary coil because of the primary. Okay. So we calculate that and then we get an expression in terms of mutual inductance. Similar way, we for the primary coil, we also calculate that. That is the flux linking with the primary because of the secondary. Alright. Again, we calculate the mutual inductance of that. So we compare these two mutual inductances, and since these two are the same, we get M is equal to mu naught N1 N2 A into L. Okay. So this is the complete derivation, and this derivation is very important. So please go through the video again.